Good morning, good morning, good morning, good morning. Happy Baby Friday. I think all my buttons are working. I was a little worried that they weren't. Honestly, I hit the button and it didn't start the show, so made me concerned. Good morning to the chat. Thanks for joining. We're trying something a little bit different today. We are using ultra low latency mode. Ultra low latency mode. That means that between what I am saying and what you are hearing, there is only about a 4-second delay. So we should be able to get a little bit more real-time communications going, I hope. If you're on the live stream, that is. If you are joining me on the recording, then, it's going to be perhaps days, months, years between the time that I'm speaking and the time that you're watching. Who knows? We are still on a journey to try to make a real-time IRL subtitle necklace with a Raspberry Pi 4. We abandoned the Raspberry Pi Zero because it didn't have enough giddy up to run Mozilla's deep speech automatic speech recognition software, or ASR, automatic speech recognition. The Raspberry Pi 4 is just faster than the Raspberry Pi Zero. All around, it is a faster clock speed. It offers more RAM, but it does consume more current. And that is one of the things I want to explore today. How much more current are we going to consume with the Raspberry Pi 4 versus the Raspberry Pi Zero? And I guess we should get into it here. I think I can get into it. Are my buttons? There we go. Oh, man. My buttons are working, but they are slow. Let's get the right thing on the screen. All right. There we go. There is our Raspberry Pi 4. This morning, let's start the show. Start. What do we actually? Let's put a title up here. First, turn this on. You should be able to see me typing. What do we need it to say? I think we need it to say, how much more current will our Raspberry Pi 4 require? How much more current will our Raspberry Pi? How much? I can't even read. How much more current will our Raspberry Pi 4 require for our project? I'm very curious. Actually, it is a thing that I'm curious about because we are trying to use a battery, this little battery right here. And we have this whole set of LEDs. We have our mic hat. The mic hat doesn't use much current. The LEDs use about 760 milliamps. How much current does the Raspberry Pi 4 use when it's cranking through all of its processing? I'm not sure. The first thing that we need to do is to try to get the LEDs. The first thing we need to do is try to get the text from our speech onto the LEDs. So we had gotten, let's see where's my code window here? Code. Here we go. We're looking at it. We had been using this streaming example that came with Mozilla's deep speech package in Python, and it outputs the text to the command line, which is good because it lets us see what the speech-to-text engine is doing. And it does that right, where does it do it? Right here, where it prints the text. So print recognized string, and it is printing the text, and the text is coming from our finished stream, hopefully working with our microphone. Now, this morning, when I turned all of this on and I just tried to make that work, course, the microphone had stopped working for some unknown reason. I had to reinstall the microphone, which was no fun at all. Also, I was a little nervous that it wasn't going to work. So let's make sure that what we had working is still working, because I turned it off and back on. Oh, to turn it off and back on. I did not realize that was going to be such a big deal. Let's see. We need to get into the proper directory. All right. And we know that our deep speech examples are there. And I think I can do Python 3. And we want to do deep speech examples, microphone bad streaming, microphone bad streaming. PY, that's what we want to do. And we have to tell it the model we want to use. So the model will be deep speech. We'll find it there. The deep speech dash 0.8. Uh-oh. There we go. 8.2 dash models. I should probably rename this model to something not quite so long. Okay. If I run this, will it start and actually begin listening? Are you listening? Microphone. I hope you are. At the very least, it didn't crash. So that's a good sign, I would say. I'm not sure. I might have to change the command that I'm using to run it. But it didn't crash. It did not crash. So that's a good sign. Let's go back to the browser, because we are looking at this blog post that's on the Seeed Audio website. We keep going back to it. And here we go. This is him microphone streaming. I don't care about L. Bad 3. Okay, so let's try this again. I think, hold on. If I'm not mistaken, let me go to CD, the examples. So one of the things that it mentions in here is it's like, if I go to the README, which we have looked at before, but I want to see where we can select the device. So I can select a device with the device index right here. If I go back to keep going between the terminal and the browser. So I'm looking at the README file for this microphone streaming, and I can select the device with the device index from piaudio.get device info by index. And I think, if I'm not mistaken, let's close that. I think this program right here, get device index, should tell me the device index. Index. Playback, vmix, array. There we go. Index 0. Hardware 2,0. So index 0 is my Seeed Audio mic voice card. So let's go back and see if we can figure this out. Okay, so if I just try to run it here, let's try it one more time. Go back. Bad. There we go. So I want to say D0 for device 0 and V3 for the voice activated detection. Is it happy about that? Are you happy about that? I think you're working. Are you working though? It might take a moment. Before it was taking a moment to load up. It does say listening. And before, though, we had the spinner, and now I don't have the spinner. I very well could have broken this accidentally. I am not sure. Well, I know for a fact that the audio board doesn't use much current. So I'm wondering about working on this code offline. I already did a little bit of offline coding. If in doubt, reboot. That is a good point. If in doubt, reboot. Let us, you know what? That's not terrible advice from the chat. The chat making a good point. We can do that. Let's go over here to my HDMI window and see if we do reboot this, what does it look like? Okay, everything's shutting down, which is a good sign. While it does shut down, I'm gonna have some water, some hipster water here. This is a new flavor, by the way. This is limoncello hipster water. Crazy. It kind of tastes like cream soda, which is weird. Okay, we're booting up. Everything booted up well. Ah, my Seeed voice card even managed to bring itself back to life. And we are back. We're back, baby. We're back. New terminal window. Let's go back to this terminal. There we are. There we are. All right. Got the new terminal window. Still haven't changed any of the passwords. Why would we change passwords? Is the question. Let's see if the card is listed. Yes, it is. And it is listed here as well. And if I try to record a thing, let's see, a record. Let's just do temp.wave. Okay, let's just do record temp.wave. Okay. Let's see. Record. Hold on. A record. I think I gotta tell it the format. Format U8 temp.wave. Huh. This is my worry. This is my worry. So, the show sponsor for this limoncello LaCroix water. I take it. I do like this water. It's weird how much I've gotten into the sparkling water. I find it a wonderful substitute for soda. I used to drink a ton of Coke, but it turns out drinking a ton of Coke when you get older, not great. Probably not great when you're younger, but really not great as you age. You don't just shed it like you used to when you were younger. So this gives me the sparkly bubbles that I enjoyed, and I really enjoy this flavor. It's kind of weird. So a weird thing happened when I just tried to issue that command and make the recording work. Some lights turned on the LEDs. That is so weird. Oh. The Joe from the chat saying, can't I find Perrier? I mean Perrier. Whoa, Perrier. No Perrier. No Perrier, just LaCroix. Perrier. I don't know if Perrier has the limoncello flavor. It's the limoncello flavor. If you can find it, seriously, if you can find limoncello flavored LaCroix sparkling water at your local grocery store, buy it, try it, let me know what you think. I'm very interested. Well, So I have a problem. I have a problem with the microphone install, and I thought I'd solved it. It appears like I have not solved it. I'm not sure why issuing a record command turns on the lights. That's kind of exciting. But you know what? We don't need any of that, honestly, to accomplish our goal of measuring the current. Let's see, I have a LED test. So let's take a look. I think the LED test, I want to say it flashes the LEDs. Yes, it fills them up, it sleeps, it turns them off, it sleeps. And we were doing this before to test our current. So let's just Python 3, make sure it still works. Uh-oh. Oh my goodness, I thought the very simple thing of flashing LEDs was going to be beyond our capabilities, but you have to run it with Sudo. There we go, we're flashing. There we go. You see the flashing on the screen, I assume. That actually looks pretty good. Let's stop it. Let's stop it. And we're going to make a slight change to our setup. Let's back up the camera so we can see a little bit more. We're going to disconnect. Can we see everything? There we go. Now we can see the multimeter and, oh, we see the LaCroix, the multimeter, and the Raspberry Pi, and the LED. So I'm going to disconnect my USB, and it's a Raspberry Pi 4, so it uses USB Type-C, and I have a whole series of adapters to get the current measured on this thing. So I'm going to go USB Type-C, Type-A, Type-A to my breakout board. Ta-da! I am also curious to see what voltage this is running at. So let's grab some cables from the back over here. Got one cable. I have now. Oh, that's not the cable I want. Actually, that'll work. That'll work. That'll work. We got two cables here. Got an alligator clip. I need to make more of the J-clip cables. So I got a cable here. Cable here. Alligator clip cable. Bummer. Can I show the console window while I'm doing this? Yeah, I can. Yeah, I can. Let's do it. Let's get the console window going so you can see what I am doing on both. Uh-oh. I don't know what I just moved there. Console window, terminal. Maybe I need to make it smaller. There we go. Just over on the side. Get it over here. Boom. Okay, so the console's over on the side. We have the Raspberry Pi right here. And we have a breakout board, so we need to go from, I think we need to go, so I'm going to measure the current on the low side, voltage on the high side. I think I can make all of this happen. I think I can make all of this happen. Common. So I'm going to plug this into ground. Now I need another adapter, yet another adapter. I have this to go from Type A to Type C, so I can plug into the Raspberry Pi, and I have a breakout board for this little mini header, or micro header. So now I have adapters on adapters on adapters on adapters. I need to make sure I do this properly, so hold on. Hold on. Doing it wrong, guys. I'm trying to do it wrong. So I need to go. How do I need to go? How do I need to go? I think I need a little jumper wire here. I believe I have a bunch of jumper wires right here. So let's get a jumper wire. think real pros probably use a breadboard. Should have used the breadboard, so okay. All right, so I want to jump from VBUS, and I want to measure. I do want to measure the voltage there. Actually, I need to use my J connector. So I want to measure the voltage here. Let's connect that. And I want to measure the current on the low side. So as it flows from ground, from the Raspberry Pi back, I want to, so I have a whole bunch of headers over here. So ground, so we'll put there. It will flow from here into the multimeter, out the black wire, and then back to ground on this side. Boop. Make sure, oh, and my cable fell off. No, come back, wire. And I'm going to plug it in. And as soon as I plug it in and connect this wire, I should. So there's ground. There we go. You know what I need? Oh, I need some putty. I need some putty. Come here, putty. There we go. Got some putty. Got some putty. Stick this stuff around. Who knew a current measurement was going to be so involved? Sometimes people avoid doing series current measurements because it is so involved. It feels like you just gotta break the circuit and put in your multimeter in the circuit. You can use clamp-on current probes for the oscilloscopes. Those will never be quite as accurate as breaking the circuit. Oh my goodness. Oh my goodness. So let's stop it. We have 5 minutes. 5 minutes. Let's set the timer for 5 minutes. 1, 2, 3, 4, 5. Start. Back to main. We're going to make this current measurement. I didn't realize it was going to take so long to make the current measurement. Here we go. Ground. And okay, we're making some measurements. I want a DC voltage as my second measurement. So second function, DCV. All right. Is that going to work? Auto range. Second function, range up. Range up. Okay, there we go. We got some things happening. We are measuring 4.8 volts. So even though it's using USB-C and it could use a different voltage than 5 volts, the Raspberry Pi 4 is still being powered with 5 volts. So it's not doing any kind of fancy high voltage stuff. And the current is, let's see. Looks like the max current was, you can't really see it. I'm going to have to tell you. Let's go zoom way in here. Can we see that? 570 milliamps is what it was getting. So I guess I'll have to read the tiny script for you. If I could ever figure out how to get that DMM's output onto the screen, that will be awesome. But so far, I have not figured that out. Before, the Raspberry Pi Zero was using 220 milliamps, and the audio board was using 30 milliamps. Now the Raspberry Pi Zero and the audio board are plugged together. So, oh my goodness, it's occasionally jumping up to 646 milliamps. So the Raspberry Pi Zero uses at least about 3 times the power of the Raspberry Pi. Did I say that backwards? The Raspberry Pi 4 is using about 3 times the current of the Raspberry Pi Zero, just chilling out Let's run a command. I think I need to open up a new terminal here. Support, log in. Can we connect? Really struggling to connect. Where are you at? Oh no. Oh no, why are we not connecting? Well, for some reason, I can't connect to this Raspberry Pi. Oh no. Oh no, I wonder. Uh-oh. Uh-oh. I wonder if my Raspberry Pi Zero is in a boot loop here. Let's check out the HDMI terminal here. I don't even see anything. I don't see anything happening here. I see a lot of frantic light happening on my Raspberry Pi Zero. We are measuring the current. We are measuring the voltage. We are not booting up. That's not good. That is not good. And somehow it kicked me offline from my stream. I am still online. I am still online. Let's see. I am still online, but my stream froze during the Pi reboot. That's weird. That is super weird. This should be back up. Let's see. Should be back up now. Huh. Okay. Let's turn it off. Let's turn it off and back on really quickly. Clear my statistics. And then hit go. Is it booting up? Is it booting up? That is so crazy. It doesn't appear to be booting. Oh my gosh. Oh my gosh. It doesn't appear to be booting up when we're trying to measure the current. Huh. That could be because it wants more information than just the 5 volts to make it work. That is so crazy. Huh. I'm kind of at I'm at a bit of a loss here. Why it wouldn't boot up. So, quick experiment before we end the show. I'm just going to disconnect what I had. I'm going to make this a little bit smaller so we can see. Put this over in the corner. So I'm going to disconnect what I had. And I'm going to go back to the way it did work before. We're not going to measure the current. We're just going to make sure it still boots up. And we're going to be very confused. Okay. Does it boot up? Yes. It does boot up when I plug the Type-C connector directly into the Raspberry Pi. It does not boot up when I try to measure the current through my series of adapters. There's going to be some thinking to do. I think the Type-C, I think the Type-C is doing some communications. I mean, it's using more than just the voltage of the Type-C over here to get the voltage or get everything set up on the Raspberry Pi. So I have to figure out, I wonder if I came in through the GPIO like I have done on past projects to measure the current, if that would be more effective. I could do that. I could do that as an experiment. But yeah, this is definitely the uncertainty principle. We are deep into uncertainty. By observing the effects, we have changed the results, which is, it is a fact of life, but kind of a bummer. So We did measure the current. I'm not sure it's the real current because the Raspberry Pi wasn't booting up properly. I might need to get a proper Type-C breakout board so that we can kind of cut into the current line there, and enable all the communications channels that are happening on Type-C that are kind of in the background that you'd never notice unless you break the link and try to measure current separately. So we learned something. Measuring current on the Raspberry Pi 4 is going to be a little bit more exciting than it was on the Raspberry Pi 3 or the Raspberry Pi Zero. So we have something to work towards on Tuesday. We also need to get our microphone working again. I suspect I'm going to have to blow the image away of the Raspberry Pi and start from scratch, which is not a big deal to have to do over the weekend, but it would take kind of a long time today. Let's see what else the chat. The default profile is 5 volts, 1 amp. Okay, so if the default profile of Type-C is 5 volts, 1 amp, and the Raspberry Pi can't tell the power supply, the Raspberry Pi power supply, that, hey, I'm a Raspberry Pi 4, please give me more than 1 amp, it will always be current starved. It will never be able to boot up, which is almost certainly the problem we are seeing. So I need to run the, oh man, I forget the little connectors that I need. There's two little wires that are the sideband communications cables for USB Type-C. I need to run those between the power supply and the Raspberry Pi to let it fully boot up. I think I can do that. I might just need some new breakout boards, which is, hey, so many breakout boards we can get to. I really appreciate you watching today. Thank you so much in the chat for the help. The communications channel, that is what I need. The chat is even still helping me. I need the communications channel between the Raspberry Pi's power supply and the Raspberry Pi 4. I don't know all the nerds in the world, but I'd love to meet them. So please share this with a nerd in your life. Maybe they'll jump on and also help me make some measurements. Current measurements should be pretty simple as long as you can get your setup correct. So let's work on getting our setup correct on Tuesday, and I will see you guys next week. I'm going to hang out in the chat for now. Thanks for watching. Bye.